Hi everybody, hope you're doing well. You're watching this video here, that means we are starting week 4 of the 4th marking period here in Algebra 1. This video is going to build off of a couple of lessons actually from the previous week in not only factoring trinomials but solving trinomial equations. So it's going to take what you learned about factoring trinomials in the previous lesson and from 2 lessons ago, the concept of zero product properties. So we're going to combine both of those things here in this video. So we're going to work through a few of the quote-unquote easier examples, and then we'll take it up about half a notch, and we'll look at some other problems that use both of these concepts together. So at the top here of the screen, you can see from the note packet here, just as a reminder of how to factor trinomials in the first place, and that is something we'll definitely emphasize through all of these problems as we go throughout the lesson. So the key thing to remember is with trinomials, the goal is this phrase, multiply to c, add to b. Two numbers that multiply to the constant and add to that middle b value, the one that is stuck to the regular x. So what we're going to do in each of these problems is, instead of just factoring, we're going to actually figure out those solutions for x. So a couple of key things we need to keep in mind. If we are solving problems like this where we see x squareds and x's, again, these are more than just your typical linear equations. Now we're moving up with other variable types, the degrees upward, etc. The fact that we have these squareds and regular x's and stuff means in order to solve these, zero product property means they must equal 0. So every problem we do throughout this has to equal 0 before we try to split it apart and try to solve it. If it's not equal to 0, you must make it equal to 0 first. And you'll see in several of these problems, we will emphasize that. But you can see off the bat here, the first couple of examples, and again, this is just pulling from the note packets, that's why we start with 9 and 10. We're going to go ahead and solve each equation. So the first check is the problem equal to 0? We can see in number 9, it is equal to 0. Awesome. Now we're going to go ahead and try to solve this. The way that we solve it is to factor it. So we are factoring a trinomial. So again, multiply to c, add to b. The goal is what multiplies to 8 and adds to negative 9. The two numbers that will do that are negative 8 and negative 1. So the way this will split apart is x minus 8 times x minus 1. Again, if this were just a factoring problem, we'd write our factors and we'd be done. But since there is that equals 0, we're going to tag that along and we're going to go one step further. If you recall from last week's lesson with zero product property, once you factor it apart, you take each factor, you set it equal to 0. That's exactly what I'm going to do here, and you solve each little equation. So in this case, you get an answer of x equals 8 and an answer of x equals 1. You get two answers for x, and in most of these problems, you will probably get that. You will get two answers. The only time where you may only get one answer is if both factors are the same, which can pop up and can happen. We're going to repeat this process through the next several problems. So if what I just did there made sense, like I always suggest, hit the pause button. Try the next one or two. If you get what I get, awesome, keep moving forward. If not, again, you can watch all the explanations as I go throughout. So the next example here, same idea. It's equal to 0, so I'm good to go there. Now I'm going to worry about factoring that left side. So I need the two numbers that multiply to 36, add to 15. The two numbers that will do that are positive 3 and positive 12. So my factor is x plus 3 times x plus 12. Set each factor equal to 0. I'll get an answer of x equals negative 3. And I'll get an answer of x equals negative 12. So again, as long as you can come up with those number pairings, again, multiply to c, add to b, if you know your times tables, hopefully this is a pretty quick exercise, then these will be pretty easy to split apart because that's going to be our emphasis for today. Because as you can see, when it comes to the equation part, these are really basic equations to solve. So we're going to go ahead and continue this here with the next several examples from the notes. And again, I know there's a lot here. It's a lot of the same stuff, but again, with this, since it is a newer skill, practicing it is going to make this a lot more automatic for many of you. Those of you that like to jump ahead and try things here, I am going to make one correction with number 15 because I realized that I had made a mistake with the values I picked. So what I'm going to actually do is I'm going to change out the 6x in the problem and make it a negative 4x. And again, those of you that like to jump ahead, the way that I had it before, it isn't that solvable. Now it is. So again, if you're jumping ahead, feel free to give that a try. All right, let's get back to where we were. So number 11, it's equal to 0. I can go ahead and factor. So what multiplies negative 15? That's negative 14. Negative 15, positive 1. Those two values meet the multiply to c add to b that it needs to do. So again, set each factor equal to 0. I'd have x equals 15. And I would also have x equals negative 1. Number 12, again, lather, rinse, repeat, same idea. It's equal to 0, so I can just go ahead and worry about factoring. Figure out what multiplies to negative 84, adds to 8. 14 and negative 6 will do that. Which means, once I solve it, x would equal negative 14. And x will equal positive 6. Now, one thing I'll note, I am showing this step every time I'm actually solving the equations. Again, some of you, probably a lot of you, can look at this and do this quickly in your head, and that's totally fine. The only reason really I would even suggest writing them out is so that way when you get the answers for x, you don't accidentally have the wrong sign for it. That tends to be where the goofy mistake occurs, where you get the factors and then just write those as your answers for x. A lot of times they're going to be the opposite of the factors that you figure out. So just again, watching those details, making sure you don't screw up signs, just like anything else. Now, 13, 14, 15, 16, it's all going to be the same idea, but there's one major difference. I said at the top of the video, they must equal 0. If they don't equal 0, you got to make them equal 0. So, we see in number 13, x squared minus 3x equals 4. I'm going to go ahead and move the 4 over. It has to be equal to 0. This doesn't work otherwise. So, when I subtract the 4 over, sometimes when you move the terms, you might be able to combine like terms. Sometimes you won't. This is an example where there are no like terms to combine. So all I'm doing is just sliding it over. Make sure whenever you rewrite the problems, if you're just moving terms, keep things in standard form from highest exponent to lowest, because that's what's going to allow this whole multiply to c, add to b pattern work. If you have the terms in the wrong order, you might come across a pair of numbers that don't actually work, or you might have a lot of difficulty trying to figure out a pair of numbers, period. So now that I've got it equal to 0, again, we figure out what multiplies to negative 4 adds to negative 3. X minus 4 and x plus 1 will do the trick. So again, I take each, set them equal to 0, so I get x equals 4, and x equals negative 1. 14, same thing. It's not equal to 0. We got to get it equal to 0. Now, typically in algebra, it doesn't technically matter which way you move your terms, theoretically. But to make this just a little bit easier, if you notice all the other problems we've done so far, the x squared has been positive. None of the problems have a negative x squared. That does not mean you can't solve for it or factor it apart when it's negative, but it takes an extra step, and you're more than likely going to get the signs backwards if the x squared is negative. So when you do these problems, if you're moving terms around, keep the x squared as positive as possible, which means I'm actually going to move the 6x by subtraction and move the 8 by adding. I don't have any like terms, so I'm going to have x squared minus 6x plus 8 equals 0. Okay? So this is an instance where I'm going to move multiple terms over. And again, I'm just showing it in the same step. If you want to do it in two waves, you certainly can. Again, it's equal to 0, so now we can go factor. Two numbers that multiply to 8 and add to negative 6. X minus 4, x minus 2. So that means I would have an x value of positive 4. And when I solve it, an x value of positive 2. 15, same idea. Got to get it equal to 0. To get it equal to 0, I'm going to move the negative 4x by adding it. And I'm going to move the negative 2 by adding it as well. Now you notice in this case, I actually have some like terms. So again, if you have like terms, add them, subtract them, whatever the signs tell you to do. So I'll have x squared. Put the x's together, I'll have 19x. Put the constants together, I'll have 90. And then the right side is equal to 0. So I can go ahead and multiply to C, add to B. Two numbers that multiply to 90 and add to 19 are 10 and 9. I solve. X would equal negative 10. And x would equal negative 9. And last but not least, number 16 for this slide. Again, I want to keep the x squared positive, so I'm going to move the 2x by subtraction and move the 8 by subtraction. So in this case, the left side is going to be 0. It's okay if the 0 is on the left, not a big deal. The right side, I do not have any like terms, so I'm just going to pull them all down. And then go ahead and do the exact same thing. What multiplies to negative 8 adds to negative 2. X minus 4, x plus 2. So my two answers for that would be x equals 4 and x equals negative 2. So there you have it, a bunch of different ways that you can, again, use the factoring trinomial strategy, a bunch of different number patterns. Again, the more that you practice these, the more automatic some of these will come up, because you see a lot of the same numbers over and over again. So again, I would definitely recommend practicing these much as you humanly can, especially if you're not as strong with coming up with those basic facts with your times tables. But again, short version of this, make sure it's equal to 0. Then make sure that you can factor it apart using this new factoring strategy, and then take the factor, set them equal to 0, and go solve for x. So the last problem I'm going to go through here is just a little bit of application. It's nothing too fancy, okay? But it's just another way that we can actually use this. Again, if we were doing this in normal class, we would go through some word problems, and if we were doing Keystone Prep, there'd be some more application to this here. But again, given the times that we're working with here, I'm just going to show you a basic version of one of those problems. So we're going to find the dimensions of a rectangle. Gives you the length of x plus 11, a width of x minus 4, and an area of 34. Now, let's talk about how to find, you've got length, width, and area. Well, how does that all relate in dealing with a rectangle? Well, finding the area of a rectangle is equal to the length times the width. So what we're going to do first is plug in all the things that go in that formula. So the area given was 34, the length was x plus 11, and the width was x minus 4. Now, one nice thing, if you look at it off the bat at face value, you see that it's been factored apart, sort of, kind of, which is great in theory. But the problem is it's not equal to 0. So we know from all the other problems, well, we can't really solve it if it's equal to something that's not 0. We know that's not the case. So why don't we go ahead and subtract 34? Now, that minus 34 is not going to mush with those two factors. We're just going to move it to the other side. So I'll have x plus 11 times x minus 4, and then a minus 34 tacked on at the end. Now, it's equal to 0, but now this doesn't look like all the other problems that we've done. This isn't exactly solvable yet, because the problem is it kind of looks like it's factored apart, but now there's minus 34s there. What exactly do we do? Problems like this where you kind of have it where it's half broken apart, half not, we need to break the whole thing apart. What we're going to do is actually put the two factors back together. Figure out what the original expression was where those two factors apart, and that'll allow us to combine terms differently so that we can actually possibly re-break the whole problem again. So we're going to combine some stuff together, fix it up a little bit so that we have all the terms that were there originally before this was broken apart, and then we're going to go ahead and re-break the problem apart. So you'll see what I'm doing here with this here in a second. So let's go ahead and multiply these together. So again, we distribute the x to both the x and the negative 4. So I'd have x squared minus 4x. Then I take the 11 and distribute it to the x and the negative 4. So I'd have 11x and negative 44. Then I pull down the minus 34 that's tacked on at the end. Now I'm going to recombine my like terms. So x squared, combine your x's, you get positive 7x. Combine your constants, you have negative 78. Now, this problem, at this step, this looks a lot nicer than what we had 2 lines above it, because It's not half broken apart, half not. This looks a lot like the problems we just have done over the last 10 to 15 minutes of this video. That's a good thing, because now what we can do is refactor this apart with that 34 included into the mix from the original start of the problem. So we're going to go ahead and use our trinomial strategy, figure out what multiplies negative 78, adds to 7. Positive 13 and negative 6 will do the trick. So now I'm going to go ahead, solve for x, get x equals negative 13, x equals 6. Now, the question was not solve for x. The question was find the dimensions of the rectangle given all these different parameters for the length, the width, and the area. So I have two answers for x. Let's go ahead, since again the question is saying what are the dimensions. That means what's the length, what's the width. So we know the length is x plus 11. We know the width is x minus 4. Well, I have two answers for x. Let's go plug them in and see what works. So I have negative 13. If I plug in negative 13 for both of these, I get a length of negative 2 and a width of negative 17. Last time I checked, you can't measure something that has a negative length or negative width. So while mathematically x equals negative 13 works, in the context of this problem, it's not a good answer. This is something that's called an extraneous solution. It's something you'll see a lot more in Algebra 2 next year, but ultimately, I don't want that answer. So negative 13, we tried it. Yeah, it spit out two numbers, but it doesn't make sense because you can't measure something that's negative 2 by negative 17. So x equals negative 13 is going to go away. Let's plug in the 6. So if I plug in 6, I get a length of 17 and a width of 2. Now those are pretty stark differences in measurements, but here's the thing. I can theoretically have something. I can have something that's definitely 17 meters by 2 meters. That is totally fine. And I've now found my dimensions. So again, if you do problems that have some application to them, and again, you'll see a lot more of this next year in Algebra 2. We're just going to scratch the surface of it now. Sometimes you do get answers where, again, in the context of an application or a word problem, yeah, maybe mathematically they make sense, but you put them into the problem, it doesn't actually work within the context of it. So again, something you'll deal with a lot more next year, but just something to keep in mind as you move forward in math. So again, this problem, this is something we'd go a lot further with. Again, if we were in class doing stuff with Keystone Prep and those sorts of things, we'll sprinkle this in a little bit as we move forward here the rest of the year. But again, nothing super, super deep here. It's just a way that I can apply what you're learning in terms of factoring with some sort of word problem, some sort of context. But at any rate, there you have it. That's how we solve trinomial equations. So again, if you understood what I did, numbers 9 through 16, you're in good shape for what I need you to know for this particular lesson. So you'll see that in the graded assignment. It's 6 or 8 questions, very similar to what you just tackled. Okay, so if you understood, again, numbers 9 through 16, you should be in good shape for the graded assignment. So make sure that you complete that, upload that in a timely manner. As always, if you have any questions, please don't hesitate. Get a hold of me. Send me a Schoology message, shoot me an email, or get on Zoom during my office hours. Again, ask me things before you submit the assignment to make sure what you're doing is correct. You all have been doing a really nice job submitting your stuff. The work all of you have been doing has been very good. Please continue with that. Very pleased with that as we go through this virtually. So again, if you need anything from me, please let me know. Otherwise, stay safe, stay healthy, and thank you for watching.